Now the last part here is about geometric interpretation, which is very important in problem. First of all, if you have vector OA with the x-axis, and if you want to find the angle of that vector, it's always the angle it makes with the x-axis. So we say that angle theta here is vector u of the x-axis with OA. Always in complex number, we want to find the relative position of 3 points. Suppose you have point M, A, B. So we need to study the relative position of these 3 points as measure of sides and of angle. For example, sometimes they ask you if they are collinear, if they ask you if we have what kind of triangle these 3 points makes, and etc. Why this ratio is important? Because Zm minus Za over Zm minus Zb is nothing else than Z of vector Am over Z of vector Bm. It's important for one reason, because you are comparing the relative position of 3 points. If you take the norm of Z, as if you're comparing side AM, norm of AM over norm of BM, and more we are comparing the argument, the angle in between. So argument of Z is nothing else than the argument of Zm minus Za over Zm minus Zb. So first of all, argument above minus below. So I have here a vector AM, and its angle with the x-axis is UAM minus down UBM. Now, if you write instead of this minus BMU, then UAM by Charles' rule, you're going to get BMAM. And if you want to switch it, take this one to that side and this one to that side, and you switch the endpoints and the beginning. So you're going to get MA and B. So what does this mean? It means if you have Z, which is equal Zm minus Za over Zm minus Zb, in norm you're comparing AM to BM, and as angle you're finding the angle BM with AM, BM with AM, or if you want MA with MB, MA with MB. So you are comparing the position of 3 points. So this geometric application is very important. So let us take example. I want to show that 3 points are collinear ABM. To show that angle ABM are collinear, so this ratio that we talked about, suppose here you have M, A, B. So this ratio that we talked about is nothing else than Zm minus Za, for example, over Zm minus Zb. So here, as we said, we are comparing norm AM with norm of BM, as angle you're finding angle MA here, MA with MB. So if angle MA with MB as answer because complex over complex will give you complex. If the angle here is R E I 0 pi, it means that they are collinear. Why? In that case, if we can prove this one, we're going to say that the angle between BM AM is either 0 or pi. 0, it means that for example MA and B same sense, pi it will be opposite sense. So in other words, if this is real, because the angle here is I0 pi, if the answer will give you this complex over complex will give you a real number, they are collinear. So let us take an example. Suppose you have Za equal to I, Zb equal minus 2i, Zc equal to plus 3i. The problem here to show that ABC are collinear. To show that ABC are collinear, we do Zb minus Za over Zb minus Zc. If you do Zb minus Za, you're going to get minus 2 minus I over Zb minus Zc minus 2 minus I minus 2 minus 3i. You're going to get minus 2 minus 2i over minus 4 minus 4i, so you can put 2 in factor down and you're going to get half. So what does it mean? So it means that I have a complex over a complex, and this will give me half ei 0. So first of all, I can say that AB in norm over CB in norm, or BA over BC if you want, BA over BC equal half. And I can say also that the angle CB with the AB sorry, equal to 0 degree. So it means they are collinear. Okay, so in that case here I can say that BC equal to BA, and they are collinear. So here BC equal to BA, and the angle between them CB and AB is 0 degree. So in that case A will be midpoint of CB. And if they are perpendicular, certainly it must be pure imaginary. Why pure imaginary? To have RE I pi over 2 plane plus or minus pi over 2. So in that case we can say that BM AM is equal plus or minus pi over 2. In that case MA and MB are perpendicular. Z equal 1 plus I radical 3, and M has of fx z, A of fx z square, and B is of fx minus z, show that MA perpendicular to MB. So this is the relative position of 3 points such that MA perpendicular to MB. So what do I do? Zm minus Za over Zm minus Zb. Zm is Z, Za is Z square, over Zm is Z, and Zb minus Z plus Z. So here I can put Z in factor and cancel this Z. I have 1 minus Z. So have into 1 minus Z, which is 1 plus I radical 3. So you're going to get minus I radical 3 over 2. What is minus I radical 3 over 2? This can be written as radical 3 over 2 E, a complex number, E minus I pi over 2. What does it mean? It means as norm إنه AM أما MA over MB equal radical 3 over 2. The relation between the two vector as norm, and angle BM with AM is equal pi over 2 or minus pi over 2. It means that AM is perpendicular to BM, what I want to show. هلا just I need this in some problems. If A, B, C, D are said to be concyclic, if for example D face arc CB and E face same arc CB, you know from brevet that we can say that they belong to the same on the periphery. A, B, C, D or D, B, C, E here are on the periphery of the same circle. So Zm minus Za over Zm minus Zb, if it's equal to K as norm, it means AM over BM is equal to K as a relation. هلا if K equal to 0, it means that A coincide with M. If K equal to M, it means MA equal MB. What does it mean MA equal MB? So M moves on the perpendicular bisector of AB. But if MA MB equal pi over 2, yani M belong to the circle of diameter AB. And if MA, for example here, suppose this is not related to the one above. If you have in a problem MA equal to R, so it means M belong to the circle of center A and radius R. So this is the complex number. I hope that you got it. So thank you for listening for these videos.